Already we have seen the t-test. Under the t-test, t distribution, we have seen confidence interval for distribution is to construct the interval x bar plus or minus t of 1 minus alpha by 2 s divided by root n. X is the sample mean, n is the sample size, s is the sample standard deviation, t of 1 minus t alpha t 1 minus alpha by 2 is the critical value from t distribution for n minus 1 degrees of freedom. We have to get this to construct this interval first to be at x bar, then plus or minus t of 1 minus alpha by 2. We have to put alpha, then to be divided by 2, then get result we have to subtract from this one, then how much you are getting you have to multiply from t. After getting this value, we have to deduct from here, multiply with this, that is s divided by root na, root n for n you know already we have seen n is the sample size, so sample size to be square root, it will be reduced that value, then for this much root n we have to divide this s value, s sample standard deviation, then how much we are getting we have to multiply with this, then plus or minus we have to add with or subtract with this. This is the construct the interval. Then the standard error is the estimate how much the average sample means will fluctuate around the true population mean. Standard error equal to how much yes sample standard deviation, we have to divide by that same how much we are getting n, if we are putting here that will be reduced only, then we have to divide by s. Okay, this is the standard error. The t critical value is simply t equal to x bar minus mu divide by s divide root n, same put n value here, already we have seen no n is the sample size, sample size we have to be square root, then divide by s for this much root n s this much, so reduce, then you have to put here x bar value mu, how much you are getting mu you have to deduct from this x bar, how much after mu deduct from x bar, then this much or this much, this result no s divided by root n, so we have to divide, that is the t critical value. Understand no? Here square n square root, then that one divided by no s s is divided by that value. So after getting this value, we have to divide by this from minus x mu. It means yes or n reduced then this much reduced this much yes. So after divide, so we are getting like this. Okay. So this is the error. Sorry, T critical value. So there we need alpha level significance, usually alpha. Here mentioned, no? Here alpha. Where we need alpha level significance, usually 0.05, 1 minus the confidence level and the degrees of freedom. The degrees of freedom TF for this type confidence interval is the simple size minus 1. For example, sample size of 12 has sample size of 12 has a expectation 90% of sample means okay will fall within 2.2 deviations. Okay, population mean we can also express this as margin of error. Margin of error, this 2.2 here we have to multiply with this s divided by root n. This is the margin of error. Okay, and the confidence interval is given as twice the mg. Okay, t test assumption of t test. The samples are unrelated or independent. The samples, for example, this is the samples are unrelated or independent. Okay, otherwise the paired t test should be used. Otherwise the pair you can test for linear independence. Linear independence. Okay. T-test assume that the underlying population variances of the two groups are equal. Variants are pooled, so you should test for homogeneity. T-test assume that T-test assume that the underlying population variance of two groups are equal where variance are pooled, so you test the homogeneity. Okay, normality of the distributions of both variables are also assumed unless the sample sizes are large enough to apply the central limit theorem. Normality of the distributions of both variables are also assumed unless the sample size are large enough to apply central limit theorem. Both samples are representative of the parent populations. Both samples are representative of the parent population. The test are robust. Even t test are robust for small sample size. robust for small sample size, except when there is an extreme skew distribution outliers. One sample test. One way test is used to compact. One way test is t-test is used to compare the mean of a sample population with the known mean. The null the null hypothesis is that there is no significant difference between the main mean population from which is your sample, which is your sample was drawn and the mean of the known population. The standard deviation of the sample is the standard deviation of the sample is the null hypothesis is that there is no significant with the difference between the mean population from the each one sample was drawn and the mean known population. The standard deviation of the sample, this is the sample. Okay, so what we are doing first, total you have to understand first square root, it means reduce the value. Okay, then what we are doing here, summation from I equal to 1 to n, what we are getting, all we have to summation add up to 1 to n, what we are getting at, that is xi, first x1 x2 x3 up to xn, n how much we are getting. Okay, this n, okay, so up to n. Okay, then x bar, that is how much we are getting x bar, you have to deduct from x1 x2 x3 x4 up to xn. Okay, then to be square, after that we have to uh, divide by this n minus 1. N minus 1, how much this n? We have to total, we have to 1 to be reduced, 1 to be deducted from n. From this we have to divide by this value, how much we are getting. Then total value to be what we are doing, square root. So it is reducing. Okay, how many times depends upon that number. If 4, 2 will come. If 16, 4 will come. For 4 to 16, 4 like this, for 9 3 like that. So how many times? 3 times it is reducing. Okay, this is the standard deviation. Okay, of the sample. This is the standard deviation of the sample. The standard deviation, how much deviate